All right, Calculus 1. I'm still in section 2.3 with one more kind of idea here. We want to try to find the velocity of a falling object at a particular time. And that is going to involve a limit. Hang on, before we can set this up, what we're talking about is a falling object. T is time in seconds. S of t is the function. That's the height. S of t is the height or the distance that it's at. So this particular object started at a height when t equals 0. You can plug in a 0. You get 300. It started at a height of 300. We just dropped this rock off a cliff. After 1 second, I plugged in a 1. After 1 second, it's at 284 feet, which means it only fell 16 feet during that second. During the next second, it fell quite a few more feet. After 3 seconds, it's at this height. I got these values by simply plugging in a time and finding the height. So as you can tell, it's falling further distance each second. That means it's speeding up, it's accelerating, and that's thanks to gravity. That's what gravity does. Gravity accelerates an object toward Earth, and so its velocity keeps speeding up every split second. Its height is changing, it's falling toward Earth, but it's also falling at a faster and faster and faster rate. It is accelerating. So to find the velocity at a particular moment is going to involve a limit. That's a little tricky. Now before we get there, by the way, it's just an upside down parabola is what this is, kind of half of an upside down parabola. Anyway, so there's this old pre-calculus idea, distance equals rate times time. And then if I want to solve for the rate would be the distance over the time, right, divided by the time. So the distance over time is the rate. And the rate is the speed, or the velocity is really what we're going to say. So that's what we're looking for. But if I just do it, this is a pre-calculus idea, if I just do the distance over the time between two distances and two times, it's the change in the distance over the change in the time, then I just get this average velocity. Watch, here's what I mean. Let's pretend I drove 400 miles and it took me 10 hours. Okay, let's find my rate. Well, I drove 400 miles, and technically that's like 400 miles is my destination minus my starting point, which was 0 miles. So anyway, I'm subtracting a couple distances, but that's my 400 miles. It took me 10 hours, so when I arrived, that was 10 hours. When I left, it was 0 hours. So again, I'm subtracting a couple times. But all that is 400 over 10, which is the change in the distance over the change in the time, and that's 40. And remember, it was miles over hours, so that's miles per hour. And that's my speed, or my velocity, or my rate. But when I took this trip, was I always going 40 miles per hour? Probably not. When I was driving out the driveway, I was going way slower than that. And when I hit the stop sign, I was actually stopped for a little while, unless I rolled it. When I got on the interstate, I was probably going 70, 80, 90, who knows. So I was going all kinds of various different speeds. So what this is this is an average speed for my whole trip. I averaged 40 miles per hour for the whole trip. That's definitely an average velocity. And we can calculate an average velocity. That's a pre-calculus idea. Let's try it with this. From 0 seconds all the way to 3 seconds. We'll skip the other ones. What is the average velocity of this falling object? Well, it would be, let me see here now. It'd be this distance. I'm going to do the distance minus the original distance, which was 300, the original height. I'm sorry, that height minus that height over that time minus that time. So it is this distance over time is it's this change in height over this change in time. It's the change in the height over in this specific problem. It's got those variables on it. Here we go. What is this? It's the change in the height, the change in time. So 156 minus 300, that's negative 144 feet, and that's 3 seconds. If I divide that, that's negative 48 feet per second. listen, it comes out negative because a velocity does come out negative. I'm falling down. I'm losing distance as I fall toward Earth, and I'm losing height as I fall toward Earth, and so it's a negative velocity. I'm falling toward Earth. Technically, I wrote all these things are the same, but technically, velocity has a positive or negative sign showing increasing or decreasing, showing increasing distance or decreasing distance. So a velocity has a positive or negative sign. Technically, speed is the absolute value of velocity. So speed is just the 48 feet per second. That's speed or rate. But velocity has the positive or negative signs. There's a technical difference there between that terminology, and I just tried to explain that. So anyway, but this, I was going slow at first, faster later. This is an average velocity. This is definitely an average velocity. Let's just do one more. Let's do the average velocity from 2 to 3 seconds. Let's do that. And so I'm going to subtract the heights and subtract the times again to get an average velocity. This time I think I'm going to subtract backwards, and it'll work. Watch. I'll do this height minus this height. So 236 minus 156, and that's okay as long as I subtract 2 minus 3. 2 minus 3. So that means that's, subtract that, that's 80 feet, and that's negative 1 second. So it comes out negative again, which it should. And this is negative 80 feet per second. So wow, that's an increased average velocity. I guess that's because I left out the first couple seconds where I was going slower. I mean, by the time I hit 2 seconds, I was going pretty fast. So this is the average velocity between 2 and 3 seconds. What that is, that average velocity between 0 and 3 seconds was technically, here's this 3-second point. It was the slope of this line. The slope of this line of a distance over time is the velocity. So that was a slope of negative 48. This was a steeper negative slope between 2 and 3 seconds. Between 2 and 3 seconds, I guess technically, that was the slope of this line. Negative 80. That was the slope of the line that connected those 2 points. All right, I'm going to erase some of this. I'm trying to find the velocity at one particular time, and that's going to involve a limit. I want to find the velocity, and our book tells us this in these problems. They say the velocity at time t equals a seconds, and they say it's this. The limit as t approaches a of s of a minus s of t all over a minus t. So I want to do this. So that's a change in s over a change in t. And that change, if t approaches a, t is the variable, a is a number. If t approaches a, that change in t is going to go to 0. So sometimes another way to say this is the change in t is going to 0. This limit, but this is worded differently. Okay, this is a different way of kind of accomplishing the same thing. I'm letting t approach a. That accomplishes the same thing. The change in t is going smaller. So I want to do this at 3 seconds. I want to get rid of these average velocities, although they might be worth thinking about a little bit. And so we want to do this for at 3 seconds. What is the speed at 3 seconds? When we did the average from 2 to 3, that was probably getting closer. If I did an average from 2.9 to 3, that would be pretty close. I could do a little average velocity from 2.8 or 2.9 to 3 seconds. That would be damn close to the answer. But I can get the exact velocity at this exact moment if I do this limit. So I can estimate it numerically with some pre-calculus ideas like 2.9 and 3, or I can do it exactly with a limit idea here. So here we go. We want to do it at t equals 3 seconds. So my a is a 3. So let's try this. I'm going to do the limit as t approaches 3. I'm going to do s of 3 minus s of t. So I've got this variable t in here, all over a, which is 3 minus t. So the a is a 3. We're doing it at 3 seconds. The t is the variable t, and I'm letting the t get closer and closer to 3. So I'm letting this t get closer and closer to 3. All right, let's try this. I'm trying to do this limit. Here it is. It's the limit as t approaches 3. I'm going to move this way here a second. Let's see, what is s of 3? That means plug 3 in the function. Okay, we did that. That's 156. Minus s of t, which is just the function itself. That's just this, negative 16t squared plus 300. All over 3 minus t. All right, that's the limit I'm trying to do. By the way, what have I taught you about limits? Step 1, plug it in, see what you get. Well, you're going to get 0 over 0. You're going to get 0 over 0. So we need to do some playing around, algebraically fix this limit here. Here we go. Let's go. Limit as t goes to 3. If I distribute that negative sign, I get a positive 16t squared. I get a negative 300, which if I subtract from the 156 minus, that's negative 144, all over this 3 minus t. I'm going to keep going. If I factor out a 16, I can factor a 16 out of there. I'm left with t squared minus 9. T squared minus 9 factors into t minus 3 and t plus 3. So I did a couple little, that's t squared minus 9, which factors. Hey, I'm going to factor that, a negative sign out of that denominator, a negative 1 out of that denominator, and that leaves me a negative 3 and a positive t, which is t minus 3. When I factor a negative sign out of 3 minus t, I get t minus 3. It's kind of hard to say. Dude, that's awesome. Now this t minus 3 cancels. That gets rid of our 0 over 0 problem. I can proceed to do this limit now. I can plug in a 3 into what's left. What I get is 16 times 6 over negative 1. That is 96. That is negative 96. Negative 96 feet per second. That is not an average velocity. That is an instantaneous velocity. That is the velocity at the moment, instantaneous velocity at the moment when t equals 3, thanks to this formula and this limit idea. That's kind of tricky. You got a few of these are in the homework in section 2.3. Next video, I need to move into 2.4, 2.5. This chapter is getting close to being over. 2.4's got some big ideas about continuity, about a function being continuous. But I like this little physics problem of a falling object. We do this a lot in calculus. Thanks for listening. Good luck. And that instantaneous velocity that we found, that negative 96 feet per second, is the slope of the line again, but instead of the slope of the line between 2 points, it's not some average slope. It's the slope of this curve at t equals 3 seconds. So it's what's called the slope of the tangent line. I mean, there's a tangent line there, and the slope of that tangent line is the velocity. I mean, my previous slopes were between 2 points. They were average velocities. This slope is at 1 point. And so this slope is at 1 point. This slope is called the slope of the tangent line. Again, referred to later as the derivative. All right, thank you.